In the second proof, again, if we take the information that we're given, there's no direct relationships from that, but we can interpret the information. Q is the midpoint again, so we could say that PQ is equal to QR by definition of midpoint, same justification as the last one. This gives us a pair of sides as far as our proof is concerned. And we're also told that QT is perpendicular to PR, so we know that these angles form right angles. So we can label the right angles, but that doesn't mean they're equal. I mean, you know that they're equal, but in the logical sequencing of a proof, you have to introduce the elements, then state their relationship in order to get that. Okay? So what we can do to interpret this second piece of information here is, again, one of two things. You can either go the route of equations or you can go the route of relationships. I'll show you both. I'll start with equations. Most students will prefer just to stick with equations. So angle 1 is equal to 90 degrees. Angle 2 is equal to 90 degrees by definition of perpendicular. So here we introduce our two elements that we see are equal, but we have to demonstrate them formally. They're each equal to 90, and now if you have two things equal to the same thing, they're equal to each other. So we can make the statement that angle 1 and angle 2 are equal by transitive property. And transitive property is always equivalent to substitution. And so this gives us a pair of angles that are equal. And now we could have come to this same conclusion a different way. We could have, instead of using the equation form, we could have made the statement that angle 1 and angle 2 are right angles. Okay. That's also based on definition of perpendicular. So we could leave the same, the justification remains the same. However, if we chose this route, then the justification, we'd still come up with the same statement, and we'd only justify it differently, because here we'd use the postulate that all right angles are equal. Okay, so either of those is fine. For the other proofs that we're going to do, I'll probably just stick with the equation form, because that's what most of you, or most students, tend to prefer. Okay, so right now we have a pair of sides and a pair of angles. We need one more pair of elements. So we either need one more pair of angles. It could be either of the remaining pairs of angles, or we could try to find the other side that would include that given angles. That side is QT. We see that it's shared side between the two triangles. That's the easier one to demonstrate. And so we can just make the statement that QT is equal to itself. That gives us our third pair of elements. Its reflexive property. And now we have enough information to state congruence of triangles. PQT and RQT are congruent triangles. And the pattern is, again, don't base it on what's shown here, even though it happens to be in the right order. We have two sides. The angle is included between those two sides. So that's the SAS pattern.